might be like an R value of perhaps 0.4. And the author did a good job of just showing an image of this. And when you'll see that, in letter C, he's got R equal to 0.4, and he's got some dots that are just not as tight as these, but spread out. Okay? And what would R equal to negative 0.4 look like?
Same thing.
Same thing, but
Different.
going down. And finally, I thought I would get to this. Way up here. What if you get this?
No relation.
And so you get this after you do some study. And you get the dots all over the place. And you're like, there does not appear to be any linear relation, right? What do you think R is going to be very close to?
Zero.
Excellent. So on this, I'm going to write R is roughly, I'll just do that squiggle. R is going to be close to 0, maybe like 0.03 or 0.08 or negative 0.05. But there just appears to be no linear relation. Cool?
Mm-hmm.
Awesome. And when you might say, hey, I'm going to do a study, and I want to know which value would be like helpful and let me know if I do perhaps have a linear relation or not. This will be fine. Now, if you notice when you do your problem, and you get an R value of roughly, you get your R value of 0.8, 0.9, feel free to use the word strong. If you get an R value near like 0.4, 0.5, feel free to use the word what? Moderate. Or if you get an R value that's like very, very close to 0, you could say no linear relation, or feel free to use the word weak. Feel free to use the word weak, like there appears to be a weak linear relation. Okay? Now, do you have your textbook? Don't worry if you don't have it with you right now, but there is a table on this thing that pulls out in the back. Alright? It's table 2. And I'll just hold it up for everyone, but I'll keep it attached to my book because you might do the same thing, because you might be saying, I'm going to sell this book, so I'm not going to pull this out. I might sell this book when the class is over. This is called the critical values for the correlation coefficient. That's what it's called. And what it has in there, critical values for the correlation coefficient, for different sample sizes, it has an R value listed. And as long as you get an R value that's going to be higher than that in your positive relationship, then you could say, oh, I'm good to go with this problem. There appears to be a linear relation. Because with my sample, I'll give you an example. The cutoff for a sample size of 9, everyone, is an R value of 0.666. So if you get a sample size of 9, 0.666, you'd be like, okay, I got an R value higher than that. There appears to be a strong linear relation. Anybody looking at this table right now?
Yeah.
What's the R value, the critical value for R listed for a sample size of 8?
0.707.
707. So we're going to do this problem, and let's see if we get an R value higher than 0.707. And if we do, then there would appear to be a linear relation to the problem. Okay? Awesome. Because of course, the more and more data you get, there's more opportunity for data to be spread out. Does that make sense?
Mm-hmm.
Awesome. All right, so let's find this number. But are we going to do it by hand? We're going to use what?
Technology.
Technology. All right. So I'm going to erase this.
Yeah.
Great job. Hey, this is kind of based on slope somehow, because positive like this and negative like this, isn't it? All right. So let's go to our calculators. And I want you to go to Stat, Edit. I want you to put these in L1 and these in L2. Sound good? Put those in L1 and put those in L2. Won't take long. I'll do it myself. I know, and you're like, hey, I could have done this before class. I actually prefer to do it with you, in case someone still forgot how to do this. I go to Stat, I go to Edit. I'm going to hit the light so everyone can see this. And I got stuff already in L1 and L2, so I have to clear this stuff out, huh? So I'm going to go over to L1. I'll hit Clear, and then I'll go to L2, up arrow here. I'm not going to hit Delete. I'll hit Clear, and I'll hit Edit. Cool.
Would the
Randy.
explanatory variable always go in L1 and response variable always go in L2?
Yeah, yes, that's correct. So explanatory always goes in L1, the response will always go in L2. Cool? All right, so, good question. Hey, I'm going to go in here, 100, we got a 102, 103, 101, 105, 199, 105. I'm going to go over here, 257, 264, 274, 266, 277, 263, 258, and 275. That's good. And I'm just going to hit quit when I'm all done. So Randy, very good. Everyone, always put X in L1. Explanatory. Always put Y in L2. You go, what are you doing now? Oh, I just hit quit. Remember second mode? Get out of here. Now, when these calculators come from the factory, and then they're shipped to Best Buy and these other places where they sell these calculators, the diagnostics for finding this value are not turned on. Okay? That's the default. So all we got to do is turn this on once. So can we do it together? We're just going to do this once. We only have to do this once. We'll do it together as a class. We're going to turn a diagnostic on. So how do you do this? I want you to hit second 0. I'm going to hit second 0 to get the catalog. And I'm going to scroll down to diagnostic on. So I'm just going to hit the down arrow and just go la-di-da-di-da-di-da-di-da. I'm going to wait till I get there. Diagnostic, there's the C's, it's alphabetical. Diagnostic on is what I want. No, not off, I want on. And I hit enter. And then after you hit enter, would you just hit enter again so it says done? And if anyone got confused there, call me T, I'll do it for you. Because you only got to do this once. Right? You go, what if the batteries die? I believe it's still good to go. But you know if anybody wasn't able to do this. Cool? So now we're good. Now it can give us the R value. Yeah, I don't know why that's not a default to just give us this. You know? Alright. So we want the R value, the linear correlation coefficient. So now we go back to stat. We've got all our data in L1 and L2, true? So we'll go to stat. We're not going to hit enter because we know we just did that. Arrow over to calc. So this is new. Where have we been previously in chapter 3? What were we doing all the time in chapter 3?
One best stat.
All right, so if you just a reminder for your notes, you're like, in chapter 3, we always used one variable stats because it was one variable. But right now, we've got these two. So if we're in chapter 4, you're going to use number 4. Let me say that again. We're in chapter 4, you're going to want number 4, which is titled linear regression. Did everyone see that? Hey, remember y equals mx plus b? Yeah, see that thing right there? We'll be talking about that in 4.2. So we're all going to hit 4. And then we're just going to hit enter. As long as we got everything in L1 and L2, that's the calculator knows to read L1, L2 right now. Cool? Hey, you don't have to do this, but everyone, if you're like, but I put everything in L3, L4. Well, then you know what I could type? I could go L3, comma, L4. I could do that for the calculator, right? And then do it, but here I'm going to hit clear. Where do I have all my data? L1 and L2. Oh, then I only have to hit stat, calc, go down to number 4, and when I do this, I just have to hit enter. Cool? Pretty cool. Did it work?
It gives me another window.
Ah. So I'm going to go to here. She's got the newer calculator. I'm going to hit this. Anybody got a new calculator? We'll talk about what you have to do so it goes on past that. Let me see. So you went here. So then you're going to scroll down to calculate. And we'll just go down to here. And we'll go down. There you go. So when she has the newer, updated calculator, after she did that, she got one more screen, she said. She just had to take her down there to get down to calculate. Who else has a newer calculator? See, they've got it too. Hey, can I hit the lights now? Because we now know R. Anyone see R? 0.93. 0.938, right? So I'm going to hit the lights. We're going to start off, I'm going to put a list of questions down, everyone, and we're going to answer these. I'm going to erase this. Hey, this formula's on the formula sheet. But absolutely, you can use your calculator to find this. All right. So letter A. And what I want you to do is compute the linear correlation coefficient. All right? That means we just got to put down that number. And we'll put it right here. Everyone, does this sound good? We've got the 3 decimal places? That sound good? How about throughout this whole entire exercise, every time, we'll go out to 3 decimal places. That means after the decimal point, 3 values. All right, so I'm seeing 0.9386. 9386. I can make it 0.939. Good job, you're not around like that. That was good. They looked at the 6. They said that's higher. Yeah, so 989. So I'm going to put that. So R is roughly, you can put an R there. If you want to squiggle, you can. 0.939, because we rounded. And the letter B. And when I'm coming up with some questions from the textbook that are similar from 4.1, I would like you to comment on the type of relation that appears to exist between, I can end it there, but I want to keep going. Between what? What relation? Between club speed and distance. All right.
So should we say like strong positive?
Ooh, I love it. I'll just put a big long line here. And then I can make a nice statement here. This is what we were discussing earlier. Well, turn this off for now. Comment on the type of relation that appears to exist between club speed and distance. Boy, that's pretty high and close to 1, right? So when we come up with this description, there's one word you don't want to be missing. It's the word linear. We could say all this stuff like, I heard positive, which is outstanding. I love the word positive. I heard a strong out there. I love that too. But what word do we really got to hit?
Strong positive.
Linear. Linear means straight line, right? And this is how we talk in statistics. This, all we did was get we got this number here. So there's other things we possibly should check. So let's start out with there appears to be. All right? Yeah, that's how we talk in sets. We'll say, well, there appears to be. There appears to be. Right now, for right now, there appears to be a, are you strong? Positive or negative?
Positive.
Positive, and here's that word, don't miss it.
Linear.
Linear. Linear, and then we could just say relation. If you were like, can I say relationship? Sure. Can I say correlation? Sure. Relation's good though. There appears to be a strong positive linear relation from this. Isn't that cool?
You always say there appears to be.
Yeah, I think it's great. You'll notice throughout this whole course, we're going to be seeing stuff like this.
Okay.
Well, I'll be in the next trial, I'll go, do you guys, we'll look at some value, and they go, you know, this suggests, you know, we'll talk about that.
Okay.
There appears to be. This suggests that, et cetera, et cetera. Because in statistics, we estimate. And when we estimate, but this is cool stuff. You know, okay, in a math course, I can find the exact inverse function to another function. Great, but you go, where are you going to use that in real life, right? This stuff, we're just estimating. And there's a guy named John Tukey. He invented the stem and leaf plot. I know, it's kind of like, things are, but he invented the box plot, John Tukey. But one of my favorite statements by him, he says, far better is an estimate to a really good problem in math versus the exact answer to a boring problem. So I'll say it again. That's what's cool about statistics. It's far better in this role to come up with an estimate. That's what we do. We estimate. An estimate to a really good problem as in comparison to the exact answer to some just boring, lame problem. The inverse function is, you know, the cube root of x cubed minus 5. Great. What's that going to do for you, right? So that's what's cool about this stuff.
Does
We are
statistics
estimating.
always deal with linear? Doesn't it deal with curve or rate of change?
Yes.
It does.
Exactly, yeah.
It does deal with that.
Uh-huh.
Oh.
Isn't that cool? I'm going to go to C. All right. gonna find the equation of the least squares regression line. I'll write that on the board, but in your notes, you could put this. We're moving now into section 4.2. All right, so at this point, I just want to keep this flowing, because 4.1 and 4.2 go together. He could have made it just one section. So they go together. Now we're getting into something called linear regression. Linear regression is, we're going to come up with an equation to model the data. And we can use that to make more predictions. Maybe for a golfer right there, inside here, all right? So this is called regression, if you've heard that word before. You go, what is it? We're going to come up with a function. It'll be a straight line. And it's going to model that data. It's going to be knifing through this data like this. Like a straight line. Cool? So, let me put that on here. I'm going to say, find the equation of the least squares regression line. All right. Everyone still there, filling the sheets out? We'll come up with this. Who remembers in algebra? A line, the equation of a line. They called it Slope-Intercept Form. Y equals, watch this, mx plus.
B.
You know this. Hey, we're going to get an answer like that. We're going to get a y equals mx plus b, you bet. In stats, they like to call m a. You're probably like, what? Your whole life you've been told m is the slope, and now they like to write it like y equals ax plus b like this. Okay, which one of these is the slope though?
A.
All right, so I just want to point out, everyone, as we go through here, the number sitting in front of x, they call it the coefficient. That number, and it might have 8 values off to the decimal place, is the slope. So just for a little review, before we answer letter C, we're just making some notes for like, well, that's the slope.